Alright guys, today we're going to be talking about hydrocarbons. Hydrocarbons are an essential part of organic chemistry. Now I know what you're thinking, organic chemistry is that horrible class in college that everyone talks about. But trust me when I say that today we're just going to be talking about the first little bit. Because organic chemistry is the study of carbon compounds. So it's pretty much just the study of one element on the periodic table because that's the most versatile element on the entire periodic table. You see, because carbon is involved in animals and plants and other forms of life, they're all consisting of organic compounds, which means they all consist of carbon. That's your nucleic acids, your proteins, your fats. If you're starting to realize, oh man, these are words that I haven't seen since biology, well, nucleic acids, don't let that scare you. That's just good old DNA. Okay. The carbohydrates, the enzymes, the vitamins, those are all of the macromolecules that your biology teacher told you about, and now we're going to learn how to name them with their appropriate chemical names. The class that we're going to be working with today is something called a hydrocarbon. Now, a lot of you can probably guess by the name that it's going to contain just hydrogen and carbon, and you'd be right. Those are the most simple types of organic compounds, and they are also some of the most simple types of covalent compounds. Yes, they are covalent compounds because hydrogen and carbon are both nonmetals. Now, I know what you're thinking. You're about to say, but hey, Miss Kovach, I remember alkali metals, and that's where the hydrogen lives. Yeah, but check this out, guys. Hydrogen is labeled with blue. Nonmetals down here, they're labeled with blue. And guess what? All these guys over here, they're still blue, which means that all of them are nonmetals. So when you have a nonmetal bonding to another nonmetal, that's still a covalent compound. So let's talk about this very specific type of covalent compound called alkanes. These are the most simple type of hydrocarbons, and that's what we're going to be dealing with today. See, right up here we have methane. That might be something that sounds familiar. You might have heard of that before, but I bet you've probably heard about these two, propane and butane. These are the most common types of hydrocarbons that you've probably come into contact with. Then down here you have gasoline. The majority of you are now getting very familiar with gasoline and its rising prices. That's when you start to see something you might find familiar. You remember pent? Well, pent meant 5 when you were talking about covalent compounds, and well, it still does here. Do you remember dec? Dec meant 10, and it still does when we're talking about alkanes. So what are these? Meth and prop and bute. Well, they're all about how to write a name for an alkane, and so that's pretty much where we're going to start. Today we're going to figure out how to write a name, and we're going to do so for an alkane. Now, alkanes are hydrocarbons that only contain single bonds. That means the bond between every single carbon inside of this compound is a single bond, which means it's only sharing 2 electrons on it. None of that double bond or triple bond stuff you might have seen in covalent compounds. This time, we're sticking easy. Alkanes are easy to find because they are saturated hydrocarbons. This means that they have the maximum amount of hydrogen atoms possible on the molecule, which means if a carbon isn't bonded to another carbon, it has to be bonded to a hydrogen. This means that they follow the general formula of C to the N, H to the 2N plus 2. N can be any number as long as it's a positive number. It can be 1 or 2 or 5. It can even be 1,000. It doesn't really matter. And whatever N is going to be the number of carbon atoms you have. In order to figure out the number of hydrogens you have, we're going to be working with this formula of 2N plus 2. That means there's going to be 2 times the amount of hydrogens that there is carbons plus 2 extra ones. We're going to talk about how to use that formula when writing a formula in just a little bit. So right now we're going to focus on how to write a name. The prefix for an alkane is super important because it tells us how many carbons are going to be part of that molecule. So let's take a look. We've got meth, F, prop, and bute as our first 4. And then something nice happens. Those are the prefixes that you're used to. Look, 5 carbons, that means pent. 6, hex. 7, hept. 8 oct, 9 none, and 10 dec. These are all covalent prefixes. The only ones that are different are 1 through 4, meth, eth, prop, and bute. Now, if we're naming these, those are all the number of carbons, and we're naming them for an alkane. So everything is going to end in A-N-E. So methane, ethane, propane, butane, pentane. Those are all the names of the hydrocarbons. So how are you going to remember these first 4? Well, I've got a mnemonic for that. The first 4, meth, eth, prop, and bute, that's MEPB. Or monkeys eat peeled bananas. Oh yeah, you're welcome. All right, so let's talk about how to take that name and turn it into a formula. Remember that the formula has to have the general structure of C to the N, H to the 2N plus 2. So let's see if that holds true. Down here with methane, meth means 1 carbon. There's that 1 carbon in the center, and let's see if that holds true, that formula. If N is 1, that means that 2N plus 2 must equal 4. And guess what? There's 4 hydrogens that are surrounding that methane, and so that formula holds true. Ethane, same deal. That's C2, H to the 2N plus 2, that's a 6. Propane, same scenario. C3, H to the 2N plus 2, that makes 8. Double check that structure. And then finally, butane. C4, H to the 2N plus 2 makes 10. So every single time when you're trying to figure out the formula for an alkane, it's all dependent on the number of carbons. If you know that N value, you can figure out anything. So let's practice. Right here, we've got a formula. The key to knowing this is that there are 2 carbons. Do you remember the prefix for 2? That's right, it's F. So this is going to be F, and because it's an alkane, we end it in ane. All right, here's the challenge. Do you remember your covalent naming prefixes? How about 6? That's right, it's hex. So this is going to be hex, and it's still an alkane because it follows that formula, so we're going to end it in ane. This time, let's go backwards. Hept. That means 7. So C7, and then H to the 2N plus 2. If N is 7, then 2 times 7 is 14, plus an additional 2 is 16. Let's do prop. Prop is 3, so that's C3, H to the 2N plus 2. If N is 3, 2 times 3 is 6, plus an additional 2 is 8. And finally, octane, you guys are probably getting the picture by now, C8H18. If you're in honors, you're going to learn about alkenes and alkynes. That's when we start getting into double and triple bonds, and you'll find that in a separate video. But for now, good luck!